Alrighty. Welcome to second stream of today. Doing number theory. Just got my homework, so I'm gonna at least attempt to start it. It's kind of, I usually go to bed pretty soon because I like to wake up early. But yeah, give it a try. Let's see, there's a couple of formatting things I would like to do. This probably like for a number and then a dot, show it as bold would look better. Also, since it's nighttime, it'd be nice to have like dark mode. So I'll do that real quick. Fill black. Set text white. All right. And then also, I guess bolding numbers would be nice. \D, is that how you get digits? Is that going to align right? I don't know. It doesn't really matter. All right. This homework from first glance, like, looks kind of annoying. I haven't really read the book section yet, and there's probably a couple things I don't know how to do, so I'll have to look at that. But there's like a couple of manual calculation things, or at least seem to be manual. But I don't really want to do, like, determine whether the integer is 701 is prime by testing all primes less than or equal to. Yeah, I know, exactly. Why? It's ass. I don't want to do that. Just write a Python script to omit the LaTeX. Yeah, that's probably the move. Yeah. There's probably a fast way to do that, right? The sieve of Eratosthenes. There's also the dumb way to do it. Okay. For I in range 701. Call that prime, actually, so we can check things are divisible by it. All right, if prime, how do you do mod in Python again? It's been a while. Is it the % sign? Or no? We're gonna have to do like a double for loop here unless we use the sieve of Eratosthenes, but I kind of forget how to implement that, so probably just do a from 1 to I, and then if I this is prime is true if I mod j is 0, then it's probably a terrible naive way to do this. If is prime, I'm gonna die. Just write the code directly in types. Actually, that's like way better. Yeah, let's do it for the sake of types being Turing complete. Okay. I forgot the types could do that. Okay. Let prime equals 701. And now we want to output all the prime factors. Well, I think so. Let's enter a script block for I in range 1. We actually only have to go up to square root, which calc.square root prime, and then, oh, is it expected integer found float? Oh, we have to round this. Floor it or ceiling it? Probably ceiling to be calc.ceiling to be safe. I'm gonna make this a little smaller. Okay, and then we have another loop, this time j up to I. Could be doing Civ of Eratosthenes again, but good call whoever said do this right in types. That's really funny. Okay, so we got we need the flag. It's true if calc.remj is prime equals 0. Oh, no. IJ. It's been a long day. If is prime, then we just want to render the content per I. Okay, 1. So I guess calc. Like the remainder is probably not the right thing to do. Oh, maybe we should go from 2. Okay. That looks good. 1, 2, 3, 5, 7, 11, 13, 19, 23. Boom. And yeah, that's got to be it. That's ridiculous. Couldn't do that in LaTeX. Guess I'm gonna also Why am I still awake, eh? Are you Canadian? I wonder if there's like... No, this is probably the most efficient way to do this, but if we make this, we'll put that inside there, and then paste it again, but this time we're going to do it with 1009. Oops. Last exam of your bachelor's. What's the exam? Good luck. There's no way my professor expected the manual prime check in types. Whoever suggested that, that's Laszlo Corte. That's It's probably the highlight of my week. Okay. Then there's a couple other proofs, but oh, give another proof. My proof environment kicked in. I guess I should say I have to capture the new line. Will that work? Yeah. What joke did I laugh at? I have absolutely nothing original to say about OpenClaw. Keith, take a look at the channel name and guess. Also, look at the process name in the top left. Okay. No, I don't use OpenClaw. So there's that. There's a couple of proofs. This one is really wacky. I think so it says it kind of give another proof of the infinitude of primes by assuming there are only finitely many primes and using the following integers to arrive at a contradiction. Using the following integer. In the integer they give, this is like a little bit ambiguous to me, I guess. So the integer is the second prime, the third prime, all the way up to the nth prime. And then the first prime, the third prime, I guess the fifth prime, it's like all the odd primes. And then the first prime, the second prime, all by 1 up to n minus 1. So that'll be interesting. That's just like kind of a really weird aren't too bad, to be honest. Not for b, you just need all prime factors to have an even exponent for it to be a square, which is impossible for a prime. Oh, that's a good point. Yeah. Even exponent. Every sum end is just the product of P1, Pn, excluding Pi. It's just the product of P1. Oh. I got you. Did I write the question wrong? Because it seems like there should be a ... I'm going to check in the textbook. Where's the textbook? I don't have it open. Come on, Zathra. Oh no. Elementary number theory. I think it's that one. There we go. Let's move it to its own area. Okay. What is this? 3.2? Or 3.3? 3.2. Gotta love a janky PDF reader. 3.2 question What question was it? Eight B. Wait, what? Am I in the right section? And I can't scroll up anymore. No, that's 3.1. 8. Yep. I knew it. Good call. And I might have mistyped the first question too, probably. By testing all primes as positive divisors. Okay, I missed that part of it. Wow, I mistyped this whole homework horribly, it seems. Okay, by testing all primes doing math tired is a recipe for disaster. As positive divisors. Okay. Here's what we're gonna do. So we've got I, and then we have, for each of these we can determine whether 701 does or does not divide it. So if it's prime, we've already entered the case where it does, or where we're going to print something. And now we check if the prime divided by calc.divide, divide Euclid, performs Euclidean, what is that? Performs Euclidean division of two numbers. Results of this computation of the division the result is that of the division rounded to the integer n, such that the dividend is greater than or equal to n times the divisor. You might just want to use rem prime I 0. Rem prime I. Oh. Yeah, you're right. So if it's 0, then the prime, or then I divides the prime. And we can do this, which is only 1, so it looks like it's going to be prime. And then we can say 701, or we could say 1 divides 701. Else we can say I divides dot not prime. And maybe I guess that's clear. Could add a comma. And it looks like 1 is the only one that divides that. I'm going to remove the comma because we have the last one. So prime is prime. And then Bertram's postulate? I don't think so. Okay. Boom. Aaron, have you made anything of the caliber Sebastian Lauge has? Two does not, 3 does not. 5, 7, 19. I mean, it makes sense actually, because why would anything divide 1,009? You know, just in case, what if we make this text like red if it does? Yeah, okay, we're good. Good call. Laszlo saving me again. Oh, what's up from Uzbekistan? Yeah, Sebastian has made some pretty amazing things, honestly. Aaron, though, you seem more hardcore. Seems like you'd roll your own stuff and see. Oh, what's up, Astro Sam Dev? It's been a minute. You think it's pronounced Lage? 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 Yeah, what have you been up to, Sam? Can you review times tables and fractions? No, that's too hard. Oh, I don't want to do that. Oh. Have I tried lean? Like pure codeine? Or I guess codeine with like Mountain Dew and Jolly Ranchers. No, I'm pretty sure Obsidian is performative, I'm not gonna lie. But I don't know. Yeah, I know he's asking about lean, the programming language. I'm just trolling him. I really want to, and I think I'll probably look at it at some point, maybe this summer. I just have a lot of homework right now, but it is really cool. Okay, there's another like very rote kind of mechanically computed thing. It would be really funny to do in types. No, the theme is called vague.invim. Like Sebastian's last name, I guess. Vague leg Lauge. Wait, Sam, what have you been up to? Have you been working on any cool projects? Although you're in school too at a pretty intense place, you probably have a lot on your plate. All right. So they say three integers, p plus 2, and p plus 6, which are prime, are called the prime triple. 5 sets of prime triples. So 1, 3, and 7 are really obvious. My guess is to just like check electrical engineering projects for my channel. Very cool. Yeah, that's awesome. Okay, so I don't really want to check this manually. It seems like a lot of work. What is considered prime? Ooh, hand nerve for haptics. I'm doing like evolutionary robotics right now. My Greek roommate Jake, also his friend who's like doing a PhD at Harvard for robotics, came up and we went to some bars with him, and he was telling us all about the state of robots down there in Boston. So pretty cool. Okay. I kind of want to let's just make a quick function. Is prime takes an n, and then, well, it's going to return, let's see. The naive way to do this is n squared, which I did below, so I guess I'll just copy that. It would be kind of cool to implement Eratosthenes. Let's give it. Why is this an error? Unclosed delimiter. There we go. Okay. Return false. Return true. We actually only need the inner loop. I think. No, that was... Okay, for 2, it's the range if prime j equals 0. This is typed. I feel like a lot of people mispronounce Greek names all the time. Yo, cool programmer. Are you a channel member? I've never seen you before. No offense. Maybe I'm just forgetting. All right. Let's do Civ of Eratosthenes. It's been a long. See if it's that hard to implement. Okay. Create a list of consecutive integers from 2 through n. Initially let p equal 2, the smallest prime integer. Okay, let's do this. Square root time complexity. That's way better than n squared time complexity, which matters for the performance of this PDF. I have to re-render this every frame. What? I know how to pronounce Eratosthenes. I've taken ancient Greek. I may not know how to pronounce Sebastian Larougue's last name, but other than that, I can pronounce most things. Loop only up to square root prime would be enough. Okay. So create a list of consecutive integers from 2. Okay. Let's call this n. Let n equals range 2 up to prime. Find all the prime numbers less than or equal to a given... Wait a minute. No, I just want to verify if something is prime or not. I don't want to find all the primes. What am I doing here? This sieves out... Yeah, crossing out multiples of 2, 3... But this isn't actually what I want. I just want to rapidly verify whether or not a number is prime. Just the limit small or sieve once. Well... Actually, maybe I do want a sieve of Eratosthenes. So the idea of the problem is find all prime triplets. Well, 5 sets of them. But I can't be bothered to guess and check that. So... Oh, well, what we can do is if we run the sieve of Eratosthenes and get all the primes, then for each of those elements we can check if p and p plus 2 and p plus 6 is in there. No, this is just for fun. I think I'm supposed to do it manually. All right, sieve of Eratosthenes. Okay, so we got our range. Initially, let p equals 2. This is going to be primes, I think. So we're going to eventually start crossing things out. Enumerate the multiples of p by counting in increments. I'm going to call this Eratosthenes. Enumerate the multiples of p by counting in increments of p from 2p to n. Mark them in the list. Find the smallest number in the list. Okay, enumerate the multiples of p. So now we just go... How am I going to mark these? That's just essentially listing all the primes and checking all of them individually. Yeah, sorry, my monitor's 4:3. Wait. I did real analysis today. What's that's just essentially listing all the primes and checking all of them individually. Yeah. You know what? No, I think I'm just doing this the easier way. No need to optimize it. What I had before was fine. That is equals false, or well, and then so we check up there, and then return false or return true if it's prime. So let's check this is the case. Is prime 1, 2, 3, 4. Fuck. Damn it. Why is this wrong? Oh, I. How is it even doing that calculation? I isn't defined. No. Prime J. Okay, 4 is not prime. 3 is not prime. I think this just returns. Okay. 2, 3, 4. We should see true, true, false if this is correct. Why is this not? For J in range 2 to the ceiling of the square root of the prime. Okay, Daniel, I'll look into that in a sec. Floor instead of ceiling. Nope. Is TypeScript just Python and JavaScript fused together? What? The return statement is out of the loop. That should be fine. Range might be exclusive. Good call. Describe the start and the end. So what, we had 1. Boom. Okay. So what the heck just happened? For I in range, let's check 1,000. And we want to know if is prime of I and is prime I plus 2 and is prime I plus 6, then we output I plus 2, and I plus 6. I think I can do I plus 2 like that. Yep. I plus 6. Ha 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 ha. That's sick. Yeah, no big deal. I'm curious. What happens if we... Oh, God. I think I crashed my... Surprisingly quick. Yeah, this hit would have been way overkill. Okay, we only need 100. Well, he says find 5. 1, 2, 3, 4, 5. Beautiful. Not sure I want to verify that, but this is why you use types, in case you have to calculate something by hand and you don't want to pull out Python because you're too lazy. You can just do the calculations in line. Okay. What question should I do next? (4b). Who is saying? It's like Daniel something was saying something about. Where was that guy saying stuff? Typed script. Wait, there was a live stream titled Day 78 of Vibe Coding 8 hours a day until I'm a billionaire, number 2. Write down of your live stream. Huh. Okay. I'll just start on a problem, I guess. Or I'll go through it as establish root p is irrational for any p. So I know the proof of that for square root 2. But for an arbitrary prime, let's see, that'll be interesting. Yeah, I'm pretty sure I have ADHD. I think people like who create STEM YouTube channels like have ADHD with like 99% frequency, but I could be wrong. All right. Assuming we're going to do this with a contradiction, Yeah, you can discuss specifics of solutions. Oh shit, you're right. Good call. Still nothing divides it, so we're cool. You can solve 4b the same way you show 2 is irrational. Yeah, okay. So just with a contradiction. Assume there was a contradiction that square root p is rational. Equals a over b. Probably don't need to say is rational then. The way you get a contradiction here, right, is you say it's a over b, and then it's like lowest form, or it's most reduced. And then we square both sides, get a squared equals b squared p and then two and all their primes have the property that if p divides ab, then p divides a or p divides b. Or you can show that square root p equals ab, b squared, contradiction because the RH side prime factorization has only even half. Yeah. For p equals a squared for b squared, and then probably bad form to do this, but p equals a squared p times b squared equals a squared, and it's a contradiction on the right because prime factorization has only even powers, and on the left hand side one of the primes must have an odd power. Wait, hold on. I'm still trying to comprehend. Why is it illegal for primes to only have even powers, or the factorization? Contradiction because on the right hand side the prime factorization has only even powers. and on the left, one of the primes must have odd powers. One of the primes must have odd powers. How do you know, LHS, one of the primes must have odd powers? Yep, so P divides... Oh, P must divide A squared. P divides A, or P divides A. So A equals PK. So P squared equals PK squared. Rinse and repeat, you get A equals PK, B equals PL. But then A and B have a common factor, which is a contradiction. For the other contradiction, you know one of the primes on the left-hand side has an odd power. Because B squared is a perfect square, so all its prime powers are even, now you're slapping on another prime. Gotcha. Yeah, I think I like implies P divides A squared implies P divides A, implies P equals, or PK equals A. Some K. Then P equals, or P B squared equals PK. Squared, which implies what? Okay, I just switched tabs. Which implies P divides B squared. No. Oh my god, I'm like falling asleep there. Okay, right, and then we have, I see the algebra there, B squared equals PK squared. which means that p divides b squared. P divides b. L integers such that equals LP, substitute that in. P times PL squared equals PK squared. Well, I guess we already simplified a little bit before, but PL squared equals PK squared. Okay. Yeah, everything is better than LaTeX. All right. Yeah, that's... So 8 is pretty interesting. Can another prove the infinite primes? How does this arrive at a contradiction? We have finitely many primes. Can we show an extra prime? Oh, I have to add the dot 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 back in. Ever done it of. The infinitude of primes by assuming that there are only finitely many primes and that using the following integer arrive at a contradiction. So we need a prime that, or we need a number that's prime that doesn't equal any of the first n primes. And that's an interesting one, because it's like, so we're removing the nth prime and adding that all up. There's like a gap in each of those. I think I'm a bit less cracked than George Hotz, unfortunately, but thanks. Hmm. Using the following integer to arrive at a contradiction. Why do people watch streamers though? Like, I don't really get that. I wouldn't watch myself if I weren't me. Watching this while getting a taper fade at the barber's? No way. What's up, barber? Yeah, literally, why would you watch a stream? Like, why not just do stuff yourself? You can feel productive while procrastinating. Man, I miss those days. Gotta support small YouTubers. What? I'm a big YouTuber. Ah, you listen to have noise. Closing the stream. Procrastinating, boring homework. I mean, the way you're ripping through that number theory, are you like a grad student? What's up, Ewan? Wait, Ewan, are you lifting tomorrow? I'm kind of sick, but I want to try to hit up the sauna. But yeah, why do people watch? I guess to feel productive. I now realize like the absolute futility of watching YouTube videos and stuff to feel productive. It's fake. I usually go at 5. Maybe I should be going at 6. It's less people at 5, but it's also harder to wake up at 5. Cancel my alarm. Nah, helmet language, I'm sorry. I'm not very wise. Okay. Turning that alarm off. Wait, you get there at 6? That means you have to wake up at before 6 to wake up at 5:30. Considering 5 a.m., 9 hours might be more optimal than 10. Oh, cool. Yeah. I'm glad that I'm glad that me trashing on someone and being a dick had a good outcome for someone. I do feel kind of bad about that still, but it is what it is. I made like $1,000 off that video. Alright, I need to create a new alarm. Add alarm. 5:30. 5:40. Okay, it's set. Alright, there's that. 12 and 28. Oh, that's a good way to look at it. Yeah, I'm sick. Yeah, send zinc. I haven't gotten blood work done in a hot minute, if ever. Yeah. And for something like this stream, I'm not smart enough to do something like this on my own, but helping with tiny parts feels more productive than watching a video of it. Yeah, I can get that. All right. I think I might need some random thing from the textbook, so I'd rather show that n factorial is a perfect square as the last problem of the night, because then I gotta go to bed. N factorial is never a perfect square. Could be proved by induction, maybe? Because 2 isn't a perfect square, 2 times 3 isn't a perfect square. Yeah, maybe this is an induction proof. Proceed by induction on n. Base case. N equals 2. 2 times 3 equals 6, which is not perfect square. Inductive step. Assume, where'd it go? Assume n factorial is not a perfect square. Want to show n plus 1 factorial, I lost my spot, is not a perfect square. Okay. And then n, I mean, so then n plus 1, then we'd have n plus 1 factorial equals n factorial times n plus 1. And we know that that n factorial isn't a perfect square. And then we have two things multiplied together. One that's not a perfect square, and one that's, well, yeah, I'm not entirely sure on that, actually. I can't immediately think of something obvious. What if it's contradicted on each thing? If we assume towards a contradiction that n factorial is a perfect square, then we want to show well, okay. Assume n factorial is a perfect square. Since n plus 1 is not n factorial and n factorial isn't a perfect square, then we can say the product is not a perfect square. I guess, is that correct? Is that correct? I'm trying to think of like a counterexample. Since n plus 1 is not n. But I mean, like, can you have a situation where you're multiplying something that's not a perfect square with something that's not it? Like what about 3? So 3 isn't a perfect square multiplied by 12 gives you 36, which is a perfect square. So it seems like that doesn't hold up in some cases. Yeah, that's what I thought initially too, but okay. So what about assuming towards a contradiction that n plus 1 is a perfect square? N plus 1 factorial is a perfect square. Then there's some a squared that equals n plus 1 times n factorial. Then a divides n plus 1 times n factorial. No. I'm not sure. Honestly, I think I have to read this chapter because I'm trying to use like techniques that are too basic to prove these. Why does dark mode not work on this PDF? Alright, I'm sick. I'm going to bed.